Hello everyone, welcome to this session. It's me again. So for those joining our first session this morning, this afternoon, you actually see me here. Well, for those actually just first time joining in for this session, welcome. My name is Long from Asia Pacific University of Technology and Innovation, APU. If you have missed the first session, which the 2 p.m. session, you can always go and replay as our Facebook page or YouTube. So once again, everyone, we're going to have a series of live seminar talk. Today is the first day from 4th July until 15th July on the topic of post-COVID-19 higher education and career. So it will cover in the field of data science, cybersecurity, AI, engineering, actuarial studies, design, and also fintech. So for more information, do visit our website at www.apu.edu.my and also follow our Facebook page. So engineering program is always one of the most popular or famous courses chosen by students and also from all around the world. So now we actually have Dr. Winish and also Dr. Tang to come to talk about empowering your future in empowering future innovations with computer and mechatronic engineering. Welcome, Dr. Tang and Dr. Winish.
Hello, good afternoon. Thank you, Lung, for having us on this webinar this afternoon. It's a great pleasure of mine and my good friend and good colleague, Dr. Tang, to be here and to share our insights on the topic of today and this afternoon, which is to empower future innovation with the usage of computer and mechatronic engineering. Now, Dr. Tang, I think you are going to lead this session, being the head of school at APU, and I'm going to tag team with you and trying to give more insights and more knowledge and the future prospects in terms of innovation with the application of computer and mechatronic engineering. So let's take them through, Dr. Tang.
All right, thanks, Prof. Winish. Very good afternoon, everyone. I'm very happy to share with you a topic on empowering future innovation with computer and mechatronic engineering. So as mentioned by Prof. Winish, I will be the main presenter for this session. I'm the head of school for Disco Engineering at APU, and as mentioned by Mr. Long, Prof. Winish is the Deputy Vice Chancellor as well as Chief Innovation Officer of the university. So before we start to talk about the computer and mechatronic engineering, perhaps since this is an engineering web seminar, it's actually making sense for us to look at what happened in the industry, especially the industrialization that happened in the past, today, and the future. And hopefully later we can relate this to the focus of today's presentation. So if you look at the first one, is the first industrial revolution actually happened in the 19th century. So during that time, people will start to develop machines to replace manual labor. So no longer a lot of the work is not done by horses or cows or even human moving the machine. Humans start to develop a lot of machinery which is powered by steam engine, steam engine. And that time also it happens that a lot of factory will be started to sell up, and there is a massive urbanization that is actually happening. So move forward to 20th century, the electricity has been discovered, and hence electricity and a lot of energy sources like gas and also petroleum has been used to power the machinery. So if you remember during that time in the 20th century, one of the most famous example will be the Ford Model T assembly line. So the whole assembly line is basically powered by electricity, but you still have a human along the line to put together or to assemble the car. So during that time also, we have a massive transformation in terms of transportation. So we started to have roads, trains being built, and it actually connect people and cities together. And the third industrial revolution actually happened in 1970s. So in this particular era, we started to have automated production lines. So as I mentioned in the second industrial revolution, you still need to have people to assemble the products. in the third industry revolution in 1970s, you will have many production lines, and with the machines being programmed and also being controlled by programmable logic controller (PLC), and you will have production lines assemble the products automatically with minimum human intervention. So in the 1970s, you will start to see robots, robotic arms, and all this in order to assemble a product. However, as you may clearly see that although we have the production lines, same kind of product is being manufactured. There's no flexibility, there's no adaptability in terms of the production. So, and if you ask me, this is also where most of the industry in Malaysia, this is where we are now, yeah, the third industrial revolution with the automation and robots. And sitting here looking at the future, right, and you know that the Malaysian government has been actively promote the concept of Industry 4. So what is actually the fourth industry revolution? As you can see from the slides, it's basically a cyber and physical systems working together. So a lot of machinery now will have the ability to connect to the internet, and they will start to actually provide a lot of the process data to the cloud, yeah? And the data will be then analyzed using a concept we call big data analytics, and a lot of useful information will then be used to diagnose the condition of the machines. And machine is also start talking to each other, and they can then collaborate to complete a production. Yeah, so that is basically a very good example of physical systems, digital systems, as well as biological systems all working together in order to make it a success. So how does it relate to computer and mechatronic engineering? So I just want to put up a proposition here is that the kind of skills and competencies that you will learn in computer and mechatronic engineering is exactly what you need in order to be successful in the era of fourth industrial revolution. Yeah. So the skills that you pick up in the program will then allow you to be very successful in the industry that is implementing the fourth industrial revolution, and of course the massive digital transformation that's happening around us. So now let's move on to the next slides. So there are certain technology competencies that is being identified under Industry 4.0. So now I want to pass over to Prof. Vinesh to talk about those competencies required.
Yeah, so it's a very good stage by stage evolvement of the industrial revolution, and now we are sitting in 4.0, and 4.0 is basically categorized by the advancements in technology. And some of the core technologies that have now become very impactful in not only business and trade, but also in new product development is the areas of artificial intelligence, the areas of augmented and virtual reality, big data and analytics, and how numbers and historical data have a forceful forecasting impact into the future. And of course, when you talk about the future, you talk about real time and how the influence of the Internet of Things has sort of impacted the role of getting real-time data and the correct data in place. Now, these technology advancements, right, when adapted in the workplace, they are an enabling factor to new ways of executing work and bringing new opportunities for value creation to any business or organization. Now, this paves the way for the formation of digital ecosystems and collaborations, as well as engagement with consumer at a greater scale. Now, if you tie this in with engineering, engineering and engineers for that matter play a role in driving the new tech placement for new product solutions. So in terms of readiness for IR 4.0 for the workplace, students who would be graduates in the coming future should think about this as future careers, and engineers play a pivotal role in enabling technology application to drive the final business solutions or new product development for the areas of IR 4.0. Now, this, if you look at the competencies that are required, it is clear and very insightful that these are the new areas that a person should be focusing on. If you look at the areas that have been shown, it all involves different sectors that come together, yeah, to enable an entire, for example, you look into the manufacturing industry as one key sector, right? You look at the digitalization of the production-based industries, yeah, driven by these technologies, which all come together as a circle of technologies that impact production flow. Now, we talked about big data, AI, augmented reality, but there are also the other impactful technologies, which include simulation. How do you bring cyber physical systems into play? How do you use advanced materials, for example, in 3D printing? How do you use drone technology for monitoring? How do you use cloud engineering and cloud for that matter for data storage? And how do you integrate a system within an assembly line which is fully autonomous? Now, if you add areas like additive manufacturing, which is 3D printing, and how products can be produced in such a fast and rapid manner, the technologies become the enabler in this digital world. Now, let's move on to the next slide where we can sort of show you more details and insights of how technologies influence the curriculum, also the programs that we have for computer and mechatronic engineering in specific. Yeah, okay.
Okay, thanks, Prof. Vinesh. So now I think after Prof. Vinesh go through all the relevant competencies required, then I believe everyone will realize that now is the best time to study engineering. If we look at the key competencies identified here, a lot of the competencies can be acquired via engineering program, especially mechatronic and computer engineering. Yeah. So if you actually choose the program, it will equip you for the future. Yeah, for you to be successful in the era of Industry 4. So now I want to move on to basically to bring you through the details of the program, as well as to highlight to you what kind of activities that you will acquire and competencies you acquire if you actually study for this program. So now I want to start from the very fundamental fact that what is basically an engineer. So if you look at the definition here is that an engineer is a person that is mainly concerned with applying mathematics, scientific knowledge, and also creativity and innovation in order to develop solutions for technical, societal, and commercial problems. So as an engineer, you not only that you need to be good with your mathematics and scientific knowledge, you also need to be innovative and creative as well. Because engineer is a problem solver, we actually develop solutions to solve problems. And the solutions that we develop must also be beneficial to the society, as well as have certain commercial sense in mind, so that we are not proposing an overly expensive products. And if you take a look at the branches of engineering, basically according to the Board of Engineers Malaysia, there are 4 categories of engineering. We have chemical, mechanical, civil, and electrical. So the programs that we will focus on today is mechatronic. So mechatronic is a subcategory of mechanical engineering, and we have electrical as well. And the computer engineering is also categorized as a subcategory of electrical engineering. So now
Yeah, so
let's take a look at yeah.
I'll add in there, yeah, the characteristics that are required for an engineer. We look at all these branches, but that one thing that brings all the engineers together is the characteristics that an engineer, the attributes, right? What are the key attributes? And we're looking at, our graduate engineers, they actually find roles that match their skills. So it can be chemical, civil, electrical, and mechanical. And today we're talking about mechatronic and computing engineering. But these 2 areas, right, they have their personal skill matching attributes. So it doesn't really look upon personality and the ambition to become that sort of engineer. But most of these engineers in the area of mechatronics and computer engineering, they actually are a perfect match for the current IR 4.0 applications in the real world, whereby the attribute, skills, and the knowledge that these 2 type of engineers have. They have that attribute, which is the key thing, which is to sort of solve problems. Yeah, they have that inquisitive mindset that can contribute to developing new solutions. They have that key eye detail that allows them to sort of get to the bottom of a problem or an issue for that matter. And with that, identify areas for improvement. And that's the key characteristics that mechatronic and computer engineers can bring to the real world if you bring them and infuse them into the world of IR 4.0, where there are a lot of technologies playing a part in development. Yeah. So let's move on and let's give them more insights onto mechatronics and computer.
Okay, very well said, Prof. Inish. So let's move on to kind of the definition of computer engineering. So what is actually computer engineering? If we take a look at the definition, right, it's basically a discipline that integrates electronic engineering and computer science together in order to develop interconnected systems of computer hardware, but with intelligent software. So there are two keywords here that we need to remember, that computer engineering is basically electronic engineering in essence. However, the students under this program, they will also master essential skills of computer science so that they can build embedded system, embedded electronic systems infused with software that actually have kind of intelligence in it. Yeah. So there are certain computer software that you can have artificial intelligence, data analytics that's actually infused with the electronics part of it. So if we take a look at what you will learn in the program. So as I mentioned, right, at the bare essential of it, you will have the subject which are on the electronic side. So you will learn analog electronics, digital electronics, embedded systems such as microprocessor. You also pick up on VLSI design, very large scale integrated circuit, which allows you to actually master certain programming knowledge in VHDL programming. And apart from that, you will see that the machine vision and intelligence is also being highlighted here. So you will also master the relevant technique of artificial intelligence in order for you to actually code algorithms that have certain intelligence, yeah, in your electronic software. Apart from that, you will see that at year 1, we also have Industry 4.0. So we will actually let you appreciate the key concepts of Industry 4 so that you can then bring it forward to your placement, to your final year project, as well as group design project. And moving over, apart from the electronic focus, you will also master essential skills in IT and computer science. So if you take a look at the orange highlight here, you will actually pick up the essentials of networking. You will also learn how to troubleshoot networks, master C, C++, and Java language. You also start to code, create relevant user interface that allow you to interact with the computer systems. Apart from that, definitely, if you look at the competency just now, big data analytics, cloud computing, IoT are some of the key pillars, yeah, key competencies for Industry 4.0. And more importantly, right, when you are actually doing a project, yeah, for your final year, we will also ask you to practice what you learn for you to incorporate electronics and computer science together in order for you to develop intelligent computer systems, yeah, that is relevant to your program. Do you have anything to add on, Prof. Finish?
Yeah, so just to add on there, computer engineers are involved with in designing, building, testing, and development of high technology. As I mentioned earlier, right? These high technology devices, they range from the most powerful supercomputers to the smallest and most energy efficient microprocessors, which are now commonly rapidly being changed due to the advancements in the mobile technologies. Yeah, and microcontrollers are also used in systems where applications are such pivotal in social media, such as engines, data farms, and things like that. Now, there's a core difference between computer engineering and computer science. Yeah, and that is important for a lot of people to understand. So, in contrast to computer science and software engineering, computer engineering emphasizes on solving problems in digital hardware and at the hardware-software interface. That is a very simple difference between a computer scientist, a software engineer, and a computer engineering person. Yeah. And now, computer science focuses on understanding, basically designing and developing programs. Yeah. But the software engineer deals with building and maintaining software systems. Now, in comes the computer engineer that can interface both and bridge both areas, the hardware and software elements, and make it as a foolproof enabler in any application. And that's important for a lot of people to understand the difference between the engineer, the scientist, and the software developer. Yeah. So let's move on, Dr. Tang.
Thanks, Prof. Finish. So in summary, right, if you actually study computer engineering, you have the best of both worlds. Yeah, not only you learn the electronic aspect of it, you also learn the computer science, and you also learn how to integrate both together, yeah, in order to develop the relevant computer systems. So what kind of career that you can actually look at when you graduate? So I'm showing you here the typical job titles of computer engineering graduates. You can actually work as system engineers, computer engineers. You can even work as programmer and IT engineer, yeah, because you actually have the relevant knowledge in programming and computer systems. And if you look at the graduate destination as well, there are a lot of computer system based company you can work with, like Intel, Motorola, Infineon, AMD, and many others. And the industry really is very wide spread. You can work in software houses as programmers. You can even work in the electronics manufacturing industry. Yeah. So let's move on to the next engineering program, which is mechatronic engineering. So most of the people will have this question about mechanical engineering and mechatronics engineering. So what is the difference between them? So before we explain that, let me just go through with you what is the actual definition of mechatronic engineering. So mechatronic engineering, the name is actually invented by a Japanese company that is from 1971. Yeah, so they patented this name, but later they make it available for everyone to use. So mechatronic engineering is basically a discipline that integrates synergistically four different areas of engineering, which is mechanical, electronics, control systems, and computer systems, in order to develop intelligent autonomous machines that is human life. So if we take a look at the diagram here, mechatronic engineering sits right in the middle, and it has fast becoming a specialized area in engineering that is highly relevant for Industry 4.0. And I explained before, it actually consists key elements of mechanical, electronic, control, and computer systems. So mechatronic engineering take the best of each of these elements in order to actually let students master key competencies in order to develop intelligent machines that is really very important for Industry 4. So Prof, you have anything to add on this as well?
Yeah, I want to add to the current notion of what is the difference between a mechanical and a mechatronic engineer. It's very simple. The mechatronic engineering program and curriculum takes on board 70% of the mechanical content, right? So a mechatronics engineer, in reality, is a full-fledged mechanical engineer. But what becomes more interesting for the mechatronic engineer is that he has now developed skill sets in research, evaluation, and designing of products that will meet the IR 4.0 enabling concepts, which is areas like automation, the intelligent systems, and the development of smart devices. Now, this is important uh, moving forward as we tackle new job functions and new job roles to meet IR 4.0 vision and mission. Now, that is how the mechatronic engineer differentiates itself from the mechanical engineer. And if you talk to the industry, you will see that a lot of the experts say that mechatronics has got more in demand than mechanical, simply because mechanical is conventional, but mechatronics is the profession with the mechanical fundamentals in place for the future. Yeah. So that is a very clear description, and I thought I'll get that out there for our audience because a lot of people have asked this, and I know they've asked you and they've also asked me, why not mechanical? Why mechatronics? What is the difference? And I think that's clearly says it all now, as I've said just now. Yeah. Let's move on, Dr. Tang.
So if you take a look at the key technical competencies under mechatronic engineering, so first thing first, of course, as a student of mechatronic engineering, you have to master fundamental concepts of mechanical engineering as well. So here at Asia Pacific University, engineering, you actually learn static dynamics, strength of materials, fluid mechanics, thermodynamics, how do you design machine, and also how the production line technology is being applied. Apart from mechanical engineering, you will also study electronic as well, since an essential element of mechatronic is actually electronics. So you will actually have the usual flavor of electronics engineering, like circuits, analog electronics, digital electronics, signal processing, and also microprocessor systems. Apart from that, you also have control and automation focus as well. So as you know, automation is the key part of Industry 4, and how to make it intelligent is also another key area. So what you will master is the fundamentals of control engineering, programmer logic controller, pneumatic systems, robotic technology, CAD/CAM, machine vision, and sensors and actuators. And last but not least, in order for you to be fully skilled for Industry 4, you will also master the basic essential Industry 4 engineering software, cloud, and also IoT. So how do you actually then demonstrate that you are able to integrate all 4 areas together? So that is actually done via group design project. So at the first semester of your year 4, we will actually ask you to assemble in teams and produce prototype that have the essential elements of mechanical, electronics, control automation, and computer systems together. Apart from that, you also have an opportunity to complete a project on your own. So that is actually via final year project, where you will clearly demonstrate that you are now a mechatronic student that's ready to graduate, because you are able to produce intelligent machines that is actually able to ease human life. Apart from that, while you are at your internship at the end of year 3, you will also attach with certain companies that implement automation technology, and also for companies that implement solutions for Industry 4.0.
Now, mechatronic engineers, they work in all aspects of development of products, as I said earlier. Now, this comes from design to the testing, right to the manufacturing, and the tail end of sales and service. Yeah, there is almost no product in the world nowadays, yeah, that is slowly or solely electronic, or solely electrical, or solely mechanical in nature. So what you have just shown, right, Dr. Tang, is an entire embedment of 4 different areas into one curriculum to produce one type of engineer, which is almost like the engineer that everyone wants to have. You know why? Because with the growing capabilities of electronics, modern mechanical systems, right? And if you embed this with electronics and controls, the meaning of this is that it is in line with each discipline that allows for growing demand for mechatronic engineers who has the knowledge across the board. And this is why mechatronic engineers are becoming more in demand. Because for consumer goods such as, let's take some simple day-to-day usage. Let's talk about the microwave, let's talk about cars, let's talk about smartphones, let's talk about industrial applications such as CNC machine tools, robots, MRI, X-ray machines. Yeah, mechatronic engineers use the fundamentals as per the subject matter which you just listed out there, because these are the same fundamental principles of electrical, mechanical, software, and control engineering. They can use these fundamentals onto the design and development in order to generate a simpler, more economical, and reliable way to enhance the design, the testing, the manufacturing, and the sale of the product. So that's why mechatronic engineers create machines, yeah, for different facets around the entire manufacturing ecosystem. That includes the mechanical system, the sensing and actuation, the control systems, and the software that is the back end to sort of industrialize the entire ecosystem to fit into the 4.0 vision. And one area which is very important is the area of autonomous functions. Yeah, and in that case, the usage of industrial robots. And I think our mechatronic engineers, right, who go through our program, they actually have that entire full-scale knowledge of electronics, mechanics, and computing to carry out the day-to-day function role of a mechatronics engineer. And I think all the subjects you listed out there actually feed into that purpose. And our purpose to make our graduates ensure that they get employed. And the employment is based on a fit for purpose curriculum. And that's what we have as shown in your 4 boxes over there. Let's show them a bit about the highlights of job prospects.
Okay, thank you, Prof. Is actually a very elaborated and accurate description of the job prospects that you just described. So basically, if you look at the kind of job that you can perform as a mechatronic engineering graduate, you can work as automation engineer, mechatronic engineer, support R&D engineer, and some of the companies that you see over on the right-hand side, like ABB, Siemens, Schneider, IME, Hitachi, and all this, they are actually at the front end of Industry 4.0. Yeah, these are the companies that provide solutions for the industry to move towards Industry 4. So just to share with you, at Asia Pacific universities, our mechatronic graduates, basically when they graduate, they actually have 4 to 5 job offers already. The demand for mechatronic engineer is at the highest at the moment. And now is the best time for everyone that wanted to study engineering to look into mechatronic engineering.
Yeah, I think what we have seen is that the employment rate for our mechatronics engineers are actually 100%, because it is not only about the correct curriculum that they are coming out of, but it is also the other side of the fence, which is the demand. So the demand is so high for computer and mechatronic engineers that once you have the correct, recognized, and accredited curriculum, you actually feed so easily onto the next stage of the life cycle of a graduate, which is onto the real job. And with very close relationship with all the industries which you have mentioned there, all those names are actually key industry collaborators who are taking in our graduates simply because they have the skill sets required to do the job. Yeah, let's move on, Dr. Tam.
Okay. Just now, what we have covered is basically the essentials of computer engineering and mechatronic engineering. We have covered the key competencies that you can acquire if you are students of this program, and also what are the employment opportunity. Apart from that, I also would like to take the opportunity to elaborate on a few other programs that the School of Engineering is running. So we also have electrical electronic engineering, telecommunication engineering, as well as spectrum engineering. So all the 5 engineering programs at Asia Pacific University, they are all accredited by Board of Engineers Malaysia. So which also means that the programs are actually recognized worldwide under a Washington Accord.
Yeah, and this is a bliss. Having the Washington Accord via the Board of Engineers and the Engineering Accreditation Council, who have now come to accredit all our programs, and we are so firm with the accreditation that we have all the accreditation requirements being met. Our programs are fully accredited. Now, the Washington Accord is an international recognition. Now, we have also many international students on our program. So this has now allowed them to go back to the countries or go on to a different country to acquire jobs. And the Washington Accord recognition is a bliss for our graduates who are the international graduates who have gone on back to their countries. The degrees are recognized not only from a perspective of the Ministry of Education in Malaysia, but also from the perspective of a professional accreditation set by the Board of Engineers. And being part of these 28 signatories is a stage whereby we are on the same platform as an education that is given in any of the 28 countries. Which includes our own neighbor, Singapore, the countries of UK and the US for that matter. And our graduates have now sort of fulfilled their vision and mission and their goals of attaining a degree that they can take home with them to work in their home countries, or also work in other countries for that matter. And the same goes for our Malaysian graduates who can now embark, if they want, to other careers abroad. And I think this recognition is something that has set a very strong foundation in APU. Yeah.
Okay, thank you, Prof. So I also would like to take the opportunity to introduce the School of Engineering as the dedicated team behind all the 5 programs. Yeah. So the school is actually established in year 2006, and the academics are actually highly experienced. So we have academics from the industry, as well as we have the lab staff that managing a lot of engineering labs that we have over here. And our students are very international. So almost half of our students are coming from 62 countries around the world. Apart from that, as I mentioned before, there are engineering labs available that is suitably equipped and even highly equipped in order for the lecturers to deliver the 5 engineering programs that we have highlighted. And more importantly, apart from the teaching and learning, we also encourage staff and students to engage in research relevant to Industry 4.0. So the engineering school actually run 2 research centers. The first one is the Asia Pacific Center of Robotic Engineering, we call APCOR. The center actually focus on all kind of research and development as well as industry collaboration on the robotic area. So we have students and staff working on projects like exoskeleton, autonomous robot, intelligent robot, as well as 3D printing under the Robotic Research Center. Apart from that, we also have the Center of IoT, which is led by a lecturer in engineering as well. So at the Center of IoT, they actually focus on plenty of sensor-based technology, drones, that is basically consists of all the devices that have the connectivity to the internet.
Now it's interesting. I'm going to touch a little bit about the 2 centers that we have. The Center of Robotics, which was started in 2014, has come a long way in the last 6 years. It was started as a center to develop healthcare solutions in the form of exoskeletons for healthcare and applications for sportsmen who have lost or partially lost their flow of limbs and their workable function in terms of walking or running. Now, from that, after finding solutions for that, we have actually moved on now to applications of virtual reality and augmented reality with some infusion of AI into the oil and gas industry, where we've done some projects for our oil and gas partners, whereby you don't have to actually be at an oil and gas refinery or a platform, where you can simulate results which are tested results in a simulation form, so that you don't really develop them from a physical perspective, so that you can test and see whether it actually works. In the IoT area, we first started with a lot of sensing and devices of real-time application onto agriculture, where we had applications for mixing of soil and fertilizer and different chemicals to improve fertigation for the agriculture sector. But today, the IoT Center also does a lot of drone application research and work. And why I'm saying all about this is that the people involved with both the centers, to be specific, is the academician with a whole load of students. Our students at undergraduate and also some at postgraduate are directly involved with these kind of developments, sitting in the center, working on projects, tuning those projects directly, indirectly for their final year projects or their dissertations. So we are giving the students real-time, real-life exposure to projects which are actually in demand for the industry. And they meet again, as I said, I come back to this point of IR 4.0. So whatever that has been developed in terms of infrastructure and APU, it is fully tuned towards the embarking to meeting the fusion, mission, and goals of IR 4.0. So the School of Engineering has encompassed the entire facets that lead to that. Yeah, Dr. Tam, don't you agree?
Yes, definitely. So let's move on to the next. So what is so special about study for engineering programs at FPU? So first and foremost, as Prof. Vinish pointed out just now, the curriculum is geared towards IR 4.0. So we have 3 facets of focus that we have. Firstly, right, a theoretical foundation is very important. Apart from that, we also have students going through various different experiments in the lab, yeah, and the experiments are designed for students to acquire suitable and also relevant skills for them to be able to work in the industry once graduated. Apart from that, at each level of our program, we also focus very much on employment readiness. So we actually have a lot of activities that designed to let our students practice the real world engineering. So a lot of case studies, projects has been introduced to the student for them to actually perform problem solving as a real engineer. Apart from the curriculum, we are also very proud to say that a lot of our staff is actually possess very, very deep industry experience. So they are actually coming from industry. They work as engineers, they work as engineering manager before. So they join us at academics, and they're able to share the invaluable experience and case study with our students. Apart from that, we also have high percentage of staff with professional engineers and also chartered engineers qualification. So the staff is basically highly qualified in order to teach students, yeah, under the 5 programs that we are running. Apart from that, one area that we focus on at the School of Engineering is the industry linkages. We work with a lot of companies, and we actually invite the companies to actually fit in titles for the final year projects. So in actual fact, more than 30% of the final year project titles at the School of Engineering are provided by the industries. You have probably recognized some of the big names there, right? Like ABB, Intel, Top Glove, Vitrox, and many others. So a lot of the students, when they are at the final year, year 4, when they're working on the final year project, they are actually solving actual industry problems. So that is indeed the plus points, right? Before you graduate, you started solving problems and think like engineers. Apart from that, our students are very, very active. There are 3 student sections available at the School of Engineering. The first one is the IEM APU student section. So this is the student division of the Institute of Engineers Malaysia. Apart from that, we also have student section of Institute of Mechanical Engineers, as well as the Society of Mechatronic Engineers. So the involvement of these 3 professional organizations has enabled our students to be exposed to a lot of industry talks, a lot of industrial visits, that is basically giving them an opportunity for them to expose to the real world engineering professional practice. So that is, this 4 area basically makes the engineering program at BU very, very special. As Prof. Vinish has pointed out, employment is our key focus. So this 4 area has enabled students to be highly employable upon graduation, because while they are studying as an engineering student, they have started to acquire all the essential skills to enable them to be successful in their career as an engineer.
I think I'd like to add on the professional support given by the professional bodies and associations. Now, if I take IEM for that matter, the Institute of Engineers Malaysia, they have been very supportive in work done at APU. You know, they have come in as the professionals have come in as judges at some of our showcase final year project presentations. They've come as judges, they've evaluated, and the prizes have been given out to some of our students who have done fantastic new developments in areas of mechatronic or computer engineering for that matter. Yeah, and then year in, year out, the Institute of Mechanical Engineers UK, they have funded and supported some of the activities. Some include some of the cars that we have been developing, some of it for the sort of cars that are using solar power, some of the farm bots that we have been developing for the application into agriculture. A lot of the work has been done in trying to collaborate with SPE, and which started petroleum engineering like 4 years ago, and SPE has come on board now, since we have now started producing graduates in petroleum engineering, and SPE has got an entire library of oil and gas research work and white papers, and they give support, and they've also come in as individuals to mentor our students. And I think that the 3 professional organizations that we have supporting the university, our own lecturers and academicians are also collaborating with the professionals very well. And there is interactivity going on between the professional bodies and APU. Now, that interactivity has got a key component, and that key component are our students. Our students are directly involved with every single engagement or activity which is jointly organized between APU and the professional bodies. So that gives them that extra exposure to professionals who are not purely academics, but they're actually from the industry. Yeah, and I think that is an extra added advantage for our students. So let's move on, Dr. Tang, to the next one, where we're going to talk about program outcomes, isn't it? And how our graduate attributes, how it links up to the program outcomes. Please continue.
All right. So apart from the technical competencies that we highlighted for computer engineering and mechatronic, it's also very important that our students acquire all the other relevant competency in order for them to be successful in their career. So there are 12 program outcomes. These are basically the graduate attributes. That means that by the time of graduation, you should have the ability to attain all the 12 skills in order for you to be successful or on the right start for your engineering career. So I believe we have covered engineering knowledge just now, and also problem analysis, design, develop solution. These are very important skills of what define an engineer. Yeah. Apart from that, as an engineer as well, you will need to also have a very good understanding of project management and finance, and communication and teamwork is also very important. Apart from that, as I mentioned before, right, it's highly important for you to be able to appreciate ethics and also environmental and sustainability as well. Because as an engineer, when you are developing solution, you have to ensure that the solution that you have provided is environmental friendly, is sustainable, and also is aligned with the ethical rules and that. So these are the 12 program outcomes that we infuse at all 4 years of the engineering. All right.
I think it's very clear that you have the 12, right, Dr. Tang. You have the 12 program outcomes, and this is basically to produce graduates with the correct attributes that when they go on to the working world. And it's actually these attributes and these outcomes are set by the professional body, by the Board of Engineers, in line with, in compliance to the needs of the Washington Accord. But what is more important is that our curriculums are designed based on outcome-based education. Yeah. So in tandem with the 12 standard program outcomes, we have the learning outcomes in each and every subject that a student takes. So in computing engineering, in mechatronics engineering, as the talk for today, the attributes are there within the learning outcomes. As part of the learning outcomes, everyone is embarking on attaining the program outcomes. Now, this entire ecosystem we capture as outcome-based education. Now, we can further deep dive and call it outcome-based engineering, because you know why? You are actually producing engineers which have fulfilled the outcome, which is actually fit for purpose for the industry. So that entire channel, right? The pathway between attaining the program outcomes based on assessments conducted and ensuring that the model is practiced in accordance to industry requirements, yeah, and whatever rapid changes that happen in the ecosystem, we as a university continue to infuse CQI, continuous quality improvements, yeah, and the model keeps on changing rapidly based on the requirements of the industry. Our curriculums will change real time in accordance to what is required for the industry. Now, this is the model that we have at APU, because we are constantly monitoring the content of what is required for the attainment of the program outcomes. And we do that from a module-based benchmarking, which we have done successfully, and ensuring that it is not program-based, but it's also module and subject-based, that the content is the current content that is required in terms of knowledge and skills onto graduation. So I think what you have shown there as the 12 program outcomes is in line with OBE, our outcome-based education or outcome-based engineering that we're going to be producing for the engineers. Yeah. Let's move on to the next.
Right, thanks, Prof. Finish. So how do we ensure the 12 program outcomes are incorporated at all level of program? So first, in terms of teaching and learning delivery, there are various different activities being designed in order to achieve the 12 program outcomes or graduate attributes. So in terms of lecture and tutorial, definitely we have face-to-face lecture, but since the start of the MCO, we also move on to online. So there are various forms of delivery that we are delivering in engineering. So we have lectures, tutorials. We also have flipped classroom where we actually ask students to actually refer to certain material, and write a report before they can share with everyone in the classroom. We also very much focus on modeling and simulation activities, and also experiment, practical, and case studies as well. So these are the kinds of activities that is involved in teaching and learning in order to enable our students to acquire the 12 essential skills that is required. As I mentioned before, right, since MCO, the entire school engineering has also moved teaching and tutorial into online platforms. So in terms of online platforms, we are using Microsoft Teams, Microsoft OneNote, Whiteboard, and Stream. And it has enabled us to continue to deliver the highest quality teaching and learning possible for our students. All right.
I think
so in terms of
what
assessment,
COVID-19 and the entire lockdown is basically the opportunity to transform the way we teach and the way we teach engineering, for that matter. And this is part of the new engineering education model that we at the university have developed. So we have delivered for the last 3 months a lot of material and skills online via the digital platform that was in place. But we have also transformed the way we have delivered engineering education. And this is the part of the new model that we have designed as part of graduate development uh, through this new transformation model for engineering education. And what we have done has been successful. And we have seen students go through this model whereby virtual teaching has actually helped them in many ways. And now moving forward, post MCO, we'll have our students back for a lot of the physical activity, which include the laboratories. But the virtual learning is part of the future of globalization, whereby you will be working not in a company where physically you're delivering, but you could be working in the same company who has a different office offshore, meaning in a different country, and you could work with a globalized team delivering the objectives and the key outputs for a project. Now, what we have actually taught remotely and through the digital platform is a sample of that. And that's the transformation model that we have done and developed for engineering education at APU. And we've been successful at it. You'll definitely agree with me, Dr. Tang, that the last 3 months, the transformation model put in place for engineering has worked out very successfully.
Yes. As Prof. Vinish rightly pointed out, even in the post-COVID-19 situation, some of the online activities will likely be continued as well. So the staff and students at APU, we have realized how beneficial is it to have a lecture delivered online. Yeah, because they can actually look at the recording, and they can also have access to lecturer tutorial solution online as well. So that is indeed highly beneficial, and it will continue in some form or another post-COVID-19 situation. So moving over to assessments, apart from the very traditional assessment of final exams and practical exams, we have also put in a lot of other activities in order for our students to acquire the 12 skills that we mentioned just now. So we actually focus a lot on presentations as the key activities for our students to express the ideas, and also for them to practice communication skills. In terms of assignment, you can probably see that we have also prepared individual and also group assignment. So we want our students to work together in order to produce ideas and solutions for certain practical problems. Apart from that, we also have class tests, quizzes offered at a constant basis in order to actually assess our student understandings of those. And during the MCO also, we have also moved on successfully to use Microsoft Forms for online tests, and also using Moodle for assignment and case studies submission. And when the engineering labs are not open during MCO, we also successfully move on to virtual labs so that we can achieve the same learning outcomes with the lab-based activities by relying on systems virtually as well. Of course, definitely, as Prof pointed out, now we are in the recovery MCO era. A lot of students have started to come back to campus. So we will also resume a lot of the physical lab activities so that we ensure that the students can acquire the relevant practical skills required for them to be a successful engineer.
Yeah, I think the assessment model and strategy that we have deployed has been very well received by our students. And it is part of the what I had already mentioned about the transformation model that we have deployed for engineering education. Now, the online assessment platforms have also made it very attainable for the students in terms of good, successful results. Yeah. Now, looking forward into the real applications, right? There are a lot of professional exams which are going to be taken now online as well. And being an interviewer for the IMechE itself, I have now started to conduct professional interviews online. And a lot of the assessments which have recently been deployed for the US-based PIs have also been online. So that is the way of the future. And what we have done as part of the transformation is actually show insights to how we can adapt and adopt this new transformation model for engineering education. And I think this is the way forward. There are lots of it, which are best practices that can be deployed further, even when we come back post MCO, whereby we will have the face-to-face sessions as well. Yeah? So I do agree with you, Dr. Tang, that post-COVID, there are a lot of these best practices that will continue to work out for us. Yeah.
Yeah, Prof. Finish. I think this is indeed the new normal that we mentioned, right? The new normal in education. There is new normal in engineering education as well. Yeah. In the past, all the activities is conducted physically in the class and in the lab. But we have learned so much during the COVID-19 pandemic session, where we actually can see that there are certain activities can be done online, and students can actually benefit from those online activities as well. So post COVID-19, it actually encourages the school to think of a lot of activities which have the right mix of online as well as physical delivery, which is benefiting the students. So let's move on to talk about other aspects of the engineering program. As we all know, if you are students of engineering program, you can't be only acquiring theoretical or technical knowledge at the classrooms. It's also very important for you to appreciate what is it like to work as an actual or real engineers. So over at the School of Engineering, we are proud to say that over the last 2 years, we have conducted more than 45 talks and workshops where we invite industrial speakers, professional engineers, senior engineers, technical managers from various phases of the industry. They come to APU, they deliver and share their experience with our students. Apart from that, over the last 2 years, we had over 35 industrial visits. If you actually take out a calculator or even calculate manually, you can see that we have more than 2 industrial visits every month. So we are bringing students to various different industries. We let them actually appreciate what is it like to work as an engineer in those industries. So there are a lot of companies that we go to, including oil refinery, automotive assembly plants, research centers, and so on and so forth. Of course, during the MCO, we are not able to do this, but now we are in the recurrent MCO, and soon after, students will come back from the campus. We will resume a lot of these activities. And apart from that, I'm not too sure whether you are aware of this as well. We also have started to deliver a lot of the talks online. So over the next few months, you will see that there will be a lot of industry talks organized by the School of Engineering. We will continue to invite people and engineers from the industry to deliver the talks to you online. Yeah, and we will also broadcast live via Facebook and YouTube as well. Okay, so moving over to
I think these talks and these workshops, it is a fantastic exposure for the students, because you can learn so much in a classroom, you can learn so much in a laboratory. But what we have done as the extra effort from the university and from the School of Engineering, we are taking them to the industry. They can see for their own eyes what is going on in the industry. And a lot of these industries, even though they cover all aspects of engineering, but I can tell you today that a lot of the visits are actually quite directly tuned towards mechatronics and computer engineering as well. Because a lot of the factories, a lot of the assembly lines, a lot of the utility companies that we have visited actually deploy mechatronic and computer engineering.
Yes.
And these visits have been very beneficial for the students. They've been very well received. Now, the talks and workshops, again, a lot of these talks and workshops are in line with our collaborative partnership with the professional bodies and also the industrial companies that we link up with. And having a professional come to the university, spending 1-2 hours with the students, it gives them a direct look at how an industry practitioner is sharing the experiences he has, from the growth as an engineer to the senior leadership he is now put onto. And I think that gives them a sort of vision, and they can now sort of design their mission as a goal moving forward, taking them 5 years, 10 years down the road post graduation. And I think that's what we've done. We've done an excellent job in exposing our students to engineering practices, Dr. Tang. And I think it can only get better from what it is already at a very high peak, right, where it is right now in terms of numbers. Yeah.
Yeah, thank you, Prof. Inish. As we mentioned, we are also moving online. Even in the post-COVID-19 situation, a lot of talks and workshops will also be delivered online. So coming over to the last part of our presentation, as I mentioned before, right, engineering at APU is very unique because in terms of the curriculum, we equip students with very strong theoretical knowledge, very strong practical skills, and also employment readiness skill. And because of that, our students are very successful in competitions nationally and also internationally. And a lot of the students are actually from computer engineering and mechatronic engineering as well. So over the last 2 years, the school of engineering actually has achieved more than 15 awards and competition wins. So I'm showing you here is just some of the awards that we are actually winning. I know, Prof. Inish, when you look at these pictures, right, I think it brings back a lot of very good memory, right? So we'd like to actually share some of your thoughts on this.
Yeah, these are, the best part about a lot of these awards is our own involvement as academicians and staff with the students in getting them to reaching these wins. It is trying to nurture talent that our students have. And the students have got tremendous talent, but giving them the guidance, mentoring them towards the end goal is the key ingredient in all these major award victories. And we are very proud with our fellow staff members who have joined hands with the students in getting these awards, not only for our students who are being exposed to the industry, because most of these awards are from the industry, but also putting APU on the map in terms of what we have done as outcome-based education. And in this case, the outcomes are clearly a testament shown from the student achievement themselves. And you can see all those photos you're showing, Dr. Tang. It's a testament of the education, the engineering education, which is delivered at APU. All these outcomes, you can keep on going slide for slide. Both of us definitely know we can just keep on running slides and photos of awards for the last 5 to 6 years. And the number of awards being won by our students is just mind-blowing. Year in, year out, we can even be on MCO and we won 3 awards during MCO. And I think that is a true testament of the education being deployed at APU.
Yeah, thanks, Prof. We are so proud of our students. And as I mentioned, a lot of them are computer engineering and mechatronic engineering students. They really take on what they learn in classrooms and go on to develop solutions and ideas that enable them to win at national and international competition. And in a lot of times, do you know that the competitors is actually from master and PhD level as well? So we are so proud of them. Even our bachelor students, the ideas can match for those at the level above. So just to also show you some of the activities that we had as well. What we had over the last few years is we actually organized Engineers Day. So this is a day where our lecturers and students are having fun sessions, having a lot of interaction. So engineering is not a boring or dry subject. So we can have fun as well. So the staff actually prepare a lot of fun activities to enable us to interact with our students, to enable us to play a lot of engineering and physics games with our students. So we have had Engineers Day for the last 2 years, and definitely this year we are planning one, but we have to actually plan when the MCO is fully over.
Yeah, I think that's a really fun activity that we have for our students, because that's where we bring on a social level both the staff members and the students together. And as you can see, even senior leadership, for example, our Vice Chancellor was also on the ground to support that day in terms of activities and mingling and having fun with the students. And that social interaction between the students and the staff was simply very fascinating and nice to see, and that is what we want to do for our engineers. We don't want our engineers to be the typical timid, typical very robot mindset kind of engineers. We want them to open up. So the attributes for engineers of the future are not simply engineers who sit behind a desk, not simply engineers that are in front of a PC, not simply engineers that are always finding solution for problems, but engineers that can work in teams, engineers who can talk and present, engineers who can relate solutions to senior management, to directors of a company, engineers that can actually predict forecasting for business solutions. And this is the type of engineers that we want engineers to be thinking outside the box. But we also want engineers to sort of have a role and play the game outside the box as well, which means they're not such a fixated bunch. We are opening up the minds of engineers in terms of how they would practice in the real world in the industry.
Yeah, indeed, Prof. Vinish, I think engineers of the future, or indeed engineers of the current world, communication and teamwork is highly important. Yeah, highly important. So last but not least, right, I would like to share with you some of the e-newsletter that the school has produced. So as you can see, we have actually produced 23 volume of our Engineers Insight newsletter, and the newsletter basically documents the activities that we have actually performed at the school for the last 5 years. We also have articles contributed by the students and staff as well. So the articles will touch on topics, the engineering topics, and also even research papers by the students. So if you're interested to look at this newsletter, you can actually refer to the web link that I shared above. So I think that's all we have for today. And now it's about 5 p.m. So we can actually move on to some Q&A. So thank you very much from me. And we can now go into a question and answer session.
All right, thank you, Dr. Tang and Dr. Vinish. All right, so now we actually have some few questions actually asked by our students over here. What is the difference between computer engineering, computer science, and software engineering?
Okay, interesting. I answered that question in the beginning, Prof, but I'll answer it again.
Sure.
Yeah, go ahead. Maybe we have a different flavor to the answer because we did talk about it earlier. Dr. Tang, go ahead.
All right. So there are three areas that you highlighted here, right? So as I mentioned, computer engineering is basically a right synergy between electronics engineering and computer science. So if you actually is a student of computer engineering, you will learn how to produce embedded electronics solution, which is infused with the computer software. So basically, when you are developing computer systems, you will actually do coding, you will do programming, you will learn embedded, but you will actually master the electronic aspect, which is the hardware aspect. In terms of computer science, right? So computer science is more like a physics. So in computer science, you learn all the relevant sciences of artificial intelligence, of data science, of networking and things like that. So what you learn is basically very theoretical focus. You will not have the opportunity to actually specialize in hardware. Yeah, which is in the case of computer engineering, you will have electronics as the hardware. When you come to software engineering, right, your focus is even more narrow. You actually focus on how to write a good piece of software. So you actually focus on a lot of good practices of coding. You worry about data structure. You worry about memory size. You also worry about how do you perform good testing of the software so that the software that you produce would not actually go wrong. So as you can see, right, computer engineering gives you the right synergy between electronics engineering and computer science together. So the kind of knowledge that you acquire is not only the software, the coding aspect, you also have a very good understanding of the electronic aspect, so that you are able to produce, as I mentioned before, computer systems that be connected with intelligent software for the Industry 4.0 application.
Okay, so is Dr. Vinesh, you have anything to add on? If not, we go to the next questions.
No, that was perfect answer.
All right,
Okay.
sure. So the next questions, is it possible for mechatronics students to apply job of others field, for example, software, app computing? If yes, is there any disadvantage when competing with specific degree students, as mechatronic is a broad field?
So
I can add a little bit to this, Dr. Tang.
all right.
So basically, mechatronic engineers, they have a good sound knowledge of the fundamentals of programming. Yeah, but programming itself and software development and software engineering is also very wide. Now we have seen in the past a lot of our mechatronic engineering students who've actually moved on into software engineering jobs. Now, why they have moved on is because they got the basic fundamentals, and a lot of the programming skills are further developed when you're on the job. So the knowledge that they have on MATLAB, LabVIEW, C++, and some of the other softwares that they gain in terms of skills in the coding skills is part of the projects that they work on. Some of the languages that we are also now teaching in terms of added value workshops that we are conducting for our students are areas of Java, R, and Python. So a lot of these programming languages are slowly being attained in terms of skills by all our students. So mechatronic students now can actually venture into software companies. They will suit definitely very well, simply because they're not just coding. For them, they can actually understand that the coding has got an application. So they are coding for something that is functional. And they know that the coding is just not just end as a bunch of codes. They are coding for something that has got a direct implication on a function. And being an engineer, they can actually visualize that application and function. Yeah.
Yeah, thanks, Prof. Maybe I add on. Not to forget that mechatronic engineering also have the focus of electronics engineering as well. So if you're a mechatronic graduate, if you don't prefer to work in an industry which is highly specialized in producing automation solution, you can also work in a very broad electronic industry that we have here in Malaysia. Basically, every single industry, manufacturing processes, you will still need electronics and electrical engineers as well. So that will actually says that as a mechatronic graduate, you can virtually work in any fields. Yeah, of course, apart from chemical engineering. Okay, when there's electronics involved, when there's software involved, you can actually work there. It's not a problem.
All right. Well, sounds like we have one. Friends over here is actually still confused. She actually asking, can computer engineering do the job of computer science, or computer science is more specific than computer engineering?
Okay, maybe Prof, I try to answer that. I think this question is very similar to the first one. So that is actually down to the definition of what computer engineering is and what computer science is, right? So as I say, right, computer science is basically a very broad sciences of artificial intelligence, programming, and many others. So if you are students of computer science, you will learn, you will focus a lot on the theory and the implementation of the theory. But computer engineering, right, basically your focus is on electronics as a hardware and computer software, and how do you then link them together, yeah, when come to embedded electronic system. So you will learn coding, you will learn programming, but the purpose of your coding and programming is for you to actually program the embedded electronic systems for it to serve certain purpose. So therefore, if you allow me to say, I would say that there is no comparison between computer science and computer engineering, because there are two different areas. Yeah, two different areas. Computer science focus on algorithm development, focus on ideas, focus on theory, while computer engineering focus a lot on the practical implementation of computer science plus electronics to solve real-world problems.
All right, thank you. So next we have this. Very informative talks, as most countries are pursuing towards IR 4.0, will computer and mechatronic engineering graduates be the main guys to drive this revolution? What are your thoughts?
So over to you, Prof.
Okay. Okay, that's interesting. IR 4.0 it's a wide application, and it basically impacts a lot of industries. Yeah, every industry is now jumping on the bandwagon of IR 4.0. Now, to attain the mission of 4.0 and have systems in place, have new products being developed as solutions in place as well, to meet IR 4.0 requirements, every single engineer plays a role in IR 4.0. Even if you take a very, very conventional engineering skill set, which is civil engineering, they themselves have to have the knowledge pertaining to IR 4.0 because construction is no longer the same. Construction now has got a lot of prefabrication being done. The materials used in construction have to be produced in a much greener manner, they have to be produced in a more rapid manner. So, likewise, computer and mechatronic engineering graduates, they actually have the added advantage because they have the skill sets that are more towards automation, more towards software back-end solutions and leading towards front-end product development. They have more cyber physical exposure and knowledge, and they actually attribute towards manufacturing and new product development. Now, the manufacturing and new product development will become a feeder into applications in other sectors. So, computer and mechatronic engineers, I can't say that they will be the main guys to drive the revolution because the revolution is already in place, but definitely they fit very well in terms of the supporting cast that is required to drive the revolution onto the next stage. So from 4.0, you are definitely one day going to go on to 5.0. Now, these guys are definitely sitting very pretty in the driver's seat, moving on to the next stage of the revolution, which is coming up in the near future, which is the IR 5.0. Yeah. And I think that's basically our thoughts on that.
Yeah, just to add on, I think they're the right guys to drive the Industry 4 revolution. Rather than saying they're main guys, they're the right person because they possess all the relevant competencies in Industry 4. And as we all know, right, the revolution is here. It's not avoidable. Malaysia will soon move on and ride the boat together with other countries in the world. So therefore, they're the right person. They're the right person to equip with the right competencies for them to actually drive this.
Okay, let's move to the next questions. We have an audience here from YouTube. As a student who will be graduating from mechatronic engineering, do you suggest the student to continue with a master? If yes, what master should the student continue?
Okay, maybe I should try to answer this. Once you graduate from mechatronics engineering as an undergraduate degree, there are certainly two pathways where you can explore. Firstly, if you prefer, you can go into employment and for you to practice the skills, the competencies that you have acquired. However, if you would like to actually explore certain area in a more deeper manner, and also you have the intention to go for your masters, then definitely you can actually go to that. So when you want to study for your masters, right, what area would you like to continue? It actually boils down to the focus area of mechatronics, right? If you look at mechatronics, one of the area is machine vision, which is related to machine learning and artificial intelligence. The other area is automation as well. So if you would like to study for your masters, normally I would say that you will go for masters in robotics, you'll go for masters in machine learning or AI focus area. So that will actually deeper your skill set and your competencies relevant to mechatronic engineering.
So,
Yep.
Professor Vinish, you have anything to add on?
Yeah, just to add on, looking at the broader picture, if you are a mechatronics engineering student and if you want to study more and you don't want to go yet to the industry to work, then you can look at options that can actually add on as an advantage to your qualification as an engineer. And we have programs, for example, that relate to 4.0. We have the Masters in AI, which is a beautiful program that actually is a feeder into the new artificial intelligence or the intelligent jobs for that matter. We have the Masters in Data Science and Business Analytics. Now, that engineer is a perfect person to move into those type of programs because data scientists, data engineers, data miners, these are the new requirements in terms of job functions in the market today. And then you also learn about business analytics because then you can do forecasting and business intelligence reporting. And now you take your engineering qualification, you add on these new skill sets, and you become such a complete and total engineer that you are going to be not looking for a job. People will be looking for you. And that's a great testament when people start looking for you rather than you start looking for jobs. And we're actually producing graduates as such at our master's level, our postgraduate level, where companies are calling us to see whether we have AI, intelligent systems graduates, whether we have data scientists, whether we have cybersecurity experts, because these are the current jobs which are in demand. The engineers will always have a job because they are feeders into the new 4.0 applications and development. But these other smart jobs, as you want to call them, are also in demand a lot. Yeah.
Okay, now we go to our last questions. Is it possible to fully understand the concept in engineering through online classes?
So, Prof, I think I will let you answer that. Yeah, I think, okay, I think I will try to answer that while Prof Vinny will come back online. Yeah, so definitely for engineering, right, it's important for engineering students to have physical classes. Yeah, when we say classes, right, classes can be lectures, can be tutorials, can be lab sessions. We cannot fully go online. Yeah, the reason why we are online because of the MCO. Yeah, so ultimately for engineering students to fully acquire the skills required, we still need to come back to physical classes, especially the lab sessions. So therefore, now with the recovery MCO and student can come back, we have started to resume a lot of the physical lab sessions in order for our students to acquire the skills required. But having said that, we also found that a lot of the lecture session that we deliver can be done online as well. So what is the benefit of online classes? The sessions are recorded, so the lecturer presentation and the lecturer illustration by using Microsoft OneNote and Whiteboard, it all can be recorded. And even better is that we can actually perform collaboration as well. So we can invite students to come on board to actually provide solution live, and everything is recorded. So that's why earlier in the presentation, right, we actually mentioned that even in the post-COVID-19 situation, we are also thinking that certain activities will also be done online in order to be fully beneficial. So Prof, welcome back. So probably you want to add on to this as well?
Yeah, I know. The engineering journey is not a journey over 24 hours, neither is it a journey over 365 days. It's actually 4 years of study. And what we have seen in our practice over the last not only 3 months, because we started online digital learning way back in June and July of 2019. So what we have seen is actually a lot of adaptation and adoption, some of the pilot classes that we ran, which were running very well and well received. Now, if you talk about concepts and fundamental knowledge and the theories, and you go deeper dive into equations and solution development, that can easily be done on online classes. Yeah. Now, the trick of the matter is the physical exposure. Now, the physical means the hands-on exposure that you get in a laboratory. Now, that is tough, but look at the way engineers are being deployed in the real world nowadays. A lot of the work done in terms of simulation is actually done on online digital uh, software. Yeah, software which is being deployed to create, to design, to deploy. And I've seen even a very good example is actually some of the talks I've done recently, which is on digital twins, whereby you don't actually go to the physical presence of a oil refinery or a power plant, but you have the digital twin, which is simulated, and you deploy changes and you upgrade various systems, hardware and software, for the plants or the refinery, but you're doing it on a digital platform. Now, having said that, fundamentally, you need to attain skills of your hands-on expertise, and that can be done in laboratories, and that's what we're doing. So that's why all our students we are calling back, as you agree, Dr. Tang. Yeah, when they come back, they will still be tested, be taught and tested on all the physical activity that is required for a basic engineer. Now, that cannot go wrong. That must be there. But if I talk about the theories, the knowledge, the concepts, the software, the coding that is required to be attained by the engineer, that can be done online. Yeah, I think you'll agree on me with that. Yeah.
Yes, definitely.
All right. So today's session we're going to end here. So thank you, Dr. Tang and Dr. Vinesh. So just to remind you all again, tomorrow we have another 2 sessions. At 2 p.m., we have Professor Dr. Vinesh again on why AI and big data are skills for future job. Or for those who are interested in design, can come to join us at 4 p.m. for ecosystem for the creative industry. So once again, APU is having open day tomorrow and also next weekend on 11 and 12 July. If you are still confused on what courses you should choose for further studies, feel free to visit us and meet our counselor to find out more. So do remember to follow our Facebook page for more updates. So thank you everyone for joining us today. Goodbye.
Thank you. Goodbye.
Bye.